So today we'll be learning about diabetes, the regulation of insulin, how is insulin being released, what are the receptors associated with that, what is the ionic concentration going on, which ion is entering intracellularly, which ion is leaving the cell membrane, and then what is happening with the drugs which are responsible for controlling the glucose levels in the body, that is mainly oral hypoglycemic drugs. So we'll also be learning about the categories. So in 2-3 different chapters we'll be concluding, we'll be learning about all the different factors related to what is diabetes, what is insulin, how is it being regulated, what are the hormones which are responsible for controlling the release of insulin, what are the chemical factors responsible for controlling or increasing the release of insulin, then what are the physical factors, what are the chemical factors, neuronal factors, and then in the detailed lectures we'll be learning about what are the different drugs and how they function. Okay, so first of all, let's learn about what is diabetes. So diabetes, mainly we'll be learning about diabetes mellitus here. Diabetes mellitus. Diabetes mellitus is actually a metabolic disorder which is responsible for hyperglycemia. So when I say hyper, obviously this is the English word. Hyper means something which has been increased. When I say hypo, that means something has been decreased. When I say hyper, that means something has been increased. Now this term is related to glycemia. That is the glucose concentration. And where is this glucose concentration increasing? This glucose concentration is increasing in the blood. So when the glucose concentration goes up, it leads to the condition of diabetes mellitus. That means there is an uncontrolled increase in the glucose inside the blood, right? So basically whenever we eat food, whenever we consume food or in any other manner, however the glucose is being formed inside the human body, that glucose is somewhere stored inside the body. So whenever it is required, it is again released. So this glucose is not stored in the form of glucose, it is converted into glycogen, and then the glycogen is again released, converted back to glucose whenever required by the body for the processes requiring energy or ATP. So basically whenever we eat food directly in the form of glucose, or if there is a carbohydrate source which finally breaks down into glucose, that is stored inside the body. But somehow if that storage is not happening in an appropriate manner, and what is the hormone responsible for storing the glucose? That is insulin. Okay, so insulin is the hormone responsible for converting glucose into glycogen, and similarly glycogen is converted back to glucose by the help of hormone glucagon. We have learnt about it in previous lectures, so I am just briefing it up here. So basically we are more concerned with insulin here because glucose is responsible to be converted into glycogen and stored in the form of glycogen by the help of insulin hormone. So if insulin is not being released in an appropriate quantity, this causes a condition called as diabetes mellitus, and this diabetes mellitus is problematic because it also leads to ketonemia, it also leads to hyperglycemia, it leads to lipidemia. So these are the conditions which are which trouble the body in lot many manners. A lot of organs are damaged if there is a continuous increase in the glucose levels in the blood. So it has to be stored somehow or has to leave the body, right? Or has to metabolize. So it's a metabolic disorder. So diabetes mellitus is classified into two different categories. So we learn about them. What are the two different categories? So it is called as IDDM or NIDDM. Okay. IDDM stands for insulin dependent diabetes mellitus. So this is dependent on the insulin. NIDDM is non-insulin dependent diabetes mellitus. Okay. Insulin dependent diabetes mellitus, and this is non-insulin dependent. So this is not dependent upon the release of the insulin. So here what happens in case of IDDM, there are two factors. Either it is of type 1A or it is of type 1B. So these are the two antibodies responsible for damaging the receptors responsible for the release of the insulin hormone here. Right? So let's discuss about IDDM. In case this is actually categorized as an autoimmune disorder. So if let's just remove this thing from here. So IDDM is an autoimmune disorder. Autoimmune disorder. So when I say autoimmune, I hope again let's clarify the term here. Auto, that means self. Immune means your own immune system. We know what is immunity, how the body fights out or defends against the foreign body particles to keep itself from any kind of an infection. So here the immunity is acting on the self. The body is self-destructing its own antibodies. The antibodies are self-destructing its own cells and therefore leading to this metabolic disorder. So here we have different types, that is type 1A and type 1B. Okay, so type 1B is idiopathic. Idiopathic means that it is not identified. There is no antibody which is noted in the blood. But if the IDDM is of type 1A, then we can find the 1A antibodies in the blood. 1A antibodies can be easily found in the blood and they are responsible for destructing these beta cells. And what are these beta cells responsible for? We are very well known that insulin is being released from beta cells. So if the beta cells will be destroyed, the release of insulin will be affected. So in case of insulin dependent diabetes mellitus, this is an autoimmune disorder where the type 1A antibodies, which are easily detectable in the blood, so these antibodies are targeting the beta cells and these beta cells are responsible for its synthesis of insulin. So therefore the synthesis of insulin will be affected. Here in the case of type 1B, there is no antibody which is noted, but this is also leading to destruction of the or decrease in the levels of insulin in the blood. So ultimately there is an decrease in insulin level in the blood and it also leads to increase in the ketone bodies. So IDDM leads to ketosis, increase in the ketone levels in the blood. So this is one condition. In case of NIDDM, there is no antibody which is found. NIDDM is mostly prone in people who are above the middle age, right? And more than 90% of people suffer from NIDDM, not from IDDM. Mostly people suffer from IDDM, right? And in this case, this is a genetic condition, a genetic predisposition cases. So people who are people who have have genetic history of diabetes mellitus, in those cases people suffer from NIDDM, that is non-insulin dependent diabetes mellitus. So let's discuss a little brief about that. Here there is abnormality of the glucoreceptor. So insulin is not the problem here, the glucose receptor is the problem. The receptor have become non-responsive, or I can say the sensitivity of the receptor responsible for the release of insulin is being affected. Therefore, it is not responding to the increased glucose level. So usually what happens in the case, if there is a slight increase in the glucose levels, so automatically the beta cells will be sensitized and they will start synthesizing and releasing insulin. So now if I say these cells, the receptor of these cells are not responsive to the increased glucose levels, or the sensitivity has decreased. Oh, I'm so sorry. The sensitivity, the sensitivity has decreased, or the glucose receptors have become non-responsive to the increased glucose levels, then the beta cells will not be releasing any insulin. So insulin is not being released due to non-responsiveness, or basically it's a genetic factor, so it runs in the family sort of a thing. So the glucoreceptors are not responding to the increased levels, the sensitivity has decreased, and this affects the insulin releases. So in both the cases, the insulin is not being released. Here the beta cells are being damaged. Here the beta cells are not being damaged, but they are turning non-responsive, right? So these are the two kinds of diabetes mellitus.